All right, time for some FRQ questions. This is the 2021. I'm going to go through all of number one, but I think I'll do it in two parts just to save on time watching. I'm going to do the first couple parts. Okay, so there you're going to see one where they give you a table. Pay attention to your units here. Okay, they talk about the density of a bacteria population in a petri dish. Distance r from the center of the dish increasing, differentiable, no corners, no cusps. F of R is measured in milligrams per square centimeter. Weird units, but whatever, we're going with it. And then they give us some values for R. Okay, let me see. I am going to try, there we go. I'm going to do like this. All right, A. Use the data in the table to estimate F prime. Okay, this is F. This is position. They want slope. We have no equation to find exact instantaneous derivative. We need to estimate. That means we're going to go change in y's over change in x's. It's the best we're going to do using with correct units. Now I want 2.25. That's going to put me in between those 2 points. It'll be in between something. You just got to find the points that it's in between for. And I'm going to go change in y's over change in x's. Oh no, I don't know what I just did. There we go. And it looks like my y's are going to be 10 minus 6. And I'm going to be 2.5 minus 2. Sorry, 4. Oh my goodness. 0.5, which is going to give me 8. And my units would be, this is kind of weird, milligrams per square centimeters per centimeter. It's a rate of change of this rate, okay? And we're per centimeters because this radius is measured in centimeters. Okay, kind of strange. Anyways, that's A. And let me clear that off. Let me move this down. Let's try B. B says the total mass of bacteria is given by this equation. And it's kind of a weird one. They've got R times F of R. And it's the sum underneath that product. And then times 2 pi. We'll deal with that at the end. Approximate the value of that. Right Riemann, remember, rectangle. Using the right side, and we're going 4 subintervals. So here's my 4. 1, 2, 3, 4. 4 different subintervals. I got to use this combo though, R times F of R. Okay. I'm not going to forget about this 2 pi. All right. I'll do that at the end. So I'm going to go 4 rectangles, R times F of R. These F of R's are going to be determined by the right side, and I'm going to make rectangles. So rectangle number 1 is going to be this right here. Okay, R is going to be 1. F of R is going to be the rectangle that's created here. Okay, it's got a width of 1 and it's got a height of 2 because that's the height of the right side. That's rectangle 1. Rectangle 2. This is going to be 2. That's going to be my R value, 2. My width is going to be 1 to 2, which is 1. And my height is going to be 6 because I'm using the right side. Here comes rectangle 3. My R value is 2.5. Now here comes my rectangle, the F of R piece. That's going to have a 0.5 width and a height of 10. And then finally, my fourth rectangle is going to be a R value of 4. My width is 1.5 and my height is 18. This thing is this integral right here. Estimate. It's an approximation of it using a right Riemann sum. I would get the calculator out and crank that out, and then I wouldn't forget I got this 2 pi hanging out front. Okay, this is going to give me an estimate for this value, And this value is the area underneath this rate curve right here, okay? Which means it's going to give us an amount, which means we'd be talking about milligrams, okay? I'll let you crank that out. I'll create another video for parts C and D. Remember, this is a calculator one, so you can use it as much as you want.